Good morning, everyone. In the last session, we discussed about the enum type as well as the type conversion we identified here. So if you observe, basically, this is the integer like int value we are having. We are converting into this particular vapor class. So using this particular method called value of, we are trying to converting into this the primitive type value into vapor class. From the vapor class, again, we are trying to converting into primitive type here. Okay, so this is the way we are going to convert the primitive type to vapor class to into primitive type. This is the type conversion is happening internally automatically. Okay, so this is very important, we need to understand. And here this information is added from the 1.5 onwards. Basically this concept we'll call it as a auto boxing and auto unboxing here. Now what exactly we are doing here? What we are doing, basically we are trying to convert the values into like primitive values into object class and object values into primitive type here. So one more important information, if we observe the one more important information, what we need to understand here, basically here what I'm doing is, so integer I'm trying to create a one class here and using this particular integer, so iBobby is equals to something like 100. If we observe carefully, 100 basically it is a primitive value. 100 basically it is a primitive value. Now what I'm doing is I'm trying to converting into object type. So this is, we'll call it as a auto boxing. Getting the point. So this is, we'll call it as a auto boxing. So what we are doing, basically whatever the value we are having, we are trying to converting into vapor classes. So from the vapor classes, what we will do, we'll try to converting into primitive type. So how I'm trying to converting this? Now you can see, so whatever the IOB we are having, that is I'm trying to use into this I. Okay, IN is equals to IOB. Now, so what I'm doing here, the line number 28 here, basically 27 we are converting the primitive value into object type, and from the object type into I'm trying to converting into again primitive type here. Okay, so this is important here. Now if I'm going to print this, what happens internally? It will print the same value. For example, if I'm going to print here, if I'm going to print IN IOB. So here IN and IOB. Basically IN, it is a primitive type, IOB is our object type. If I'm going to print this, now we'll get the same value. 100 value we are getting in the two locations. So IN basically it is a primitive type and IOB basically it is a vapor type here. Now what you need to understand basically, so this is the type conversion like auto boxing as well as auto unboxing here. Everything is happening internally. We are not going to do any changes here. So this is very important. This particular operations is introduced from the 1.5 onwards here. Getting the point? 1.5 onwards, we are trying to implement this particular auto boxing as well as auto unboxing here. Now, so the same information how we can use to the methods here. Let me write a one class here, the same class here, auto boxing and okay, auto boxing and unboxing here. So here only I will try to define the main method and inside this particular main method, whatever we implemented, I'm trying to copy into this. Because we'll understand this example comes under the auto boxing and auto unboxing. And now what you need to understand this, so this is another important example we need to understand here. So static I'm trying to write because we are trying to discuss about the method here. This is the return type of this particular method, and this method what exactly it is doing here, what exactly it is doing here. So I am trying to write the method. The name of the method I'm trying to write as a method, and here it is expecting integer, integer v. Getting the point? So it is the reference variable I'm trying to add, something like v. Now, what you need to understand? So whatever the method we defined here, so now you can see it is expecting object as a parameter. Now I'm trying to converting primitive type here. Whatever the we are having, the v I'm trying to converting. But if you observe carefully, so this is the object type. Whatever the v we added here, so basically it is a object type here. Okay. So if you see v dot, you are getting these many informations here. Whenever it is an object only, we are going to get this particular informations here. Okay. For this particular primitive type, we are not going to get this information. But what we are doing here basically, whatever the objective type we are having, we are trying to converting into primitive type here. So how it is converting? Now you can see here, I'm trying to return, instead of returning the integer, I'm trying to return int here. Getting the point? I'm trying to return this particular int. This is very important. We need to understand what exactly it is going to provide the information here. The information basically, the method is expecting object, and we are trying to converting into primitive type, and we are trying to return the primitive value. Okay. So here also again we need to understand the. So this is the auto boxing, and again we are trying to do into this is a auto unboxing here. Okay, and this is we'll call it as a auto boxing, because what we are doing here, we are trying to provide the parameter, the object type. Now what I'm doing here, I'm trying to converting into auto unboxing like a primitive type. Okay, so this is the another example we need to understand. This is the another example we need to understand basically how we are converting into object class into primitive type here. So here we are not conversion, like we are not doing any explicit conversion. Everything is taken care by the our compiler, and everything internally it is converting here. Okay, and one more class I'm trying to create here, something like AutoBox 2. Okay, so this is the AutoBox 2 I'm trying to explain here. And finally, now what I will do here, I'm going to provide the information, something like, now you can see what we are having basically. I'm having integer data type here, and IOB and IOB2. See basically, if we observe carefully, IOB and IOB2, these are all the two reference variable I'm trying to create for this particular integer object. So once I created these two variable instance, like a reference variable, now what I'm trying to do here, now you can see the below I'm trying to provide the int I. I'm trying to provide int I. Now what I'm doing here I'm trying to provide the IOB is equals to 100. So whatever the value we are having, the value I'm trying to conversion into object type here. Okay. So this is the original value. I'm going to print this original value. Original value of this particular IOB here. Okay, it will print the particular 100. Now after this, now what I'm doing is I'm trying to increment in this. Now you can see with the help of this particular plus plus operator, like a pre-increment operator, I'm trying to increasing the value. Getting the point? This is important, we need to understand. I'm trying to increasing the value. So once we increase the value, basically if it is an object, how it will increase here? So explicitly only we need to write the object increment value. Getting the point? But here what we are doing is, so without creating an object and everything directly, we are doing this particular increment operations here. So plus plus IOB. And after this, now what I will do, I'm going to print the same example here. And here, so after So after something like plus plus IOB. Now, if you observe carefully, if I'm going to run the same example, so original value 100 we are getting, and after incrementing this particular increment operator, we are getting 101. How we are getting it? So this is important because the value, basically this is the value we are converting into this particular object type. So if you observe carefully what we need to understand here, now here I'm going to provide some value to this, otherwise like I is equals to something like IOB. I is equals to something like IOB. Now if you observe carefully, IOB dot, IOB dot, whenever I'm trying to create a dot here, we are getting multiple methods. We are getting multiple methods because we already discussed in the last session this particular integer class is extending from the number class. So number having some abstract method, and the abstract methods are implemented in our like integer class. Along with this, like some of the methods are coming from the object class, and some of them they are having constants variable. Now you can see max value. This max value where we define, basically we define this particular max value inside this particular integer class here. Okay, some of the constants we are getting from this particular integer class. And if I'm going to do the same operations with a primitive value, now you can see if I'm trying to make as a I dot, I'm not getting any information here. But whenever I'm trying to click on the IOB dot, because it is an object class, so it is trying to provide the information. But because of this particular primitive type, I'm not getting any information. So primitive type basically, using the primitive type, we are not going to create any objects here. So you can see it is a int. It start with a small letter, and objects are going to start with capital letters here. Okay. So earlier, whatever the example we discussed regarding this particular primitive type here. What we need to understand here, basically, with help of this particular primitive type, we are not going to create any object information. So once we are having the object, then only we are going to create an object, and we'll try to call the different methods here. Getting the point. So primitive type. Now we are discussing object type. Basically, this primitive type, basically it is a predefined data type, sir. Predefined data set. These particular values are going to store in a like a stack related information here. Getting the point. So when you're trying to change this information, and it is not going to affect it into the original locations. But here, the information, what we need to understand, basically, this is the object type. Whenever we are defining this particular object type, what happens internally? It's contain the references here. Getting the point. It contains the references information. But whenever we are trying to discuss about this particular integers, like a primitive types here, so it will not contain any references because it is a predefined data type, and integer is a wrapper classes, and we can call it as a user defined data types here. User defined data types here. So user is nothing but, so this particular class is defined by the Sun microsystem, but the syntax is same. Like whenever we are trying to create the class, and the same way they created the class. Now you can see the integer class. Observe carefully. Public final class integer. Okay. So same way we created multiple classes here. Getting the point. Same way we created multiple classes here. So this is very important information we are understanding here. Okay. So any questions regarding this particular primitive type as well as the wrapper classes?
Sir, I have one doubt. What is meant by that wrapper class, sir? I missed yesterday's session, so I'm just asking in brief. And
See,
also, I didn't understand what is primitive data type. Primitive type and integer is a class. So can you
yes, if
please?
you
Oh,
see here, if you observe carefully, int, this particular int, so all the letters it's going to start with a small letter. Those data types we'll call it as a primitive type data types. So for example, long, short, and byte. So float. This we already discussed in the initial example. Double. This we'll call it as a primitive type. And same way, we'll have a vapor classes. Like if you observe, long is a vapor class. And float also vapor class. And double. Now you can see the first letter is starting with capital. Okay.
So what
And these first
wrapper
letters
class
are
will
the,
do, sir? What
see,
wrapper
vapor
class
class
will
basically, vapor class is nothing but our same object what we created in the earlier example, box class. So if you observe, this is the box class. Now you can see how we are defining public class box, and we have some properties, and we are having constructors and methods. Same way we have a integer class. So this also same public, but only they are having some additional functionality they added. Like this particular class, it's not going to extend it to the any other classes. And now you can see it is extending from the number, and it is implementing the comparable. Along with this, so we have a some information like a maximum value. So and the maximum, what we can call it as a byte code
um,
format here. And now you can see these are all the digits we are having inside this. So it's having like the purpose of this integer class will do the different operations what we did this particular box here. So but only the same object we are going to create, and we call the specific method to perform the operations. But here, why we are calling the vapor classes? If we observe, uh, so,
Sir, is our voice audible to you, sir?
Okay, basically, like I have some internet issue. Now it is restored here. Okay, so what I'm trying to explain here, basically primitive types. Primitive type basically it will try to store the data in the stack memories, and same way the objects we are going to store in the heap memory. That is we already identified. Because for the object here, what we will do, we'll try to create object classes, and the objects are going to have the references variable. The references variable basically it is communicating with our heap memory. Okay, and same way, so inside this particular objects here, these classes we are calling as a vapor classes. Why we are calling the vapor classes? Basically, along with this particular primitive type, whatever the primitive type we are having, so same way they created the classes here. Okay, if you observe long is a primitive type, but this long is a vapor class. So basically it is a object class. Getting the point? So how we created the box class? Same way, we are going to create a long class information, and the name of this particular class we are calling as a vapor. Basically, it will do the same operations what we are doing this particular primitive type here. So that's the reason we are calling as a this particular classes as a vapor classes here. Okay. Now observe the same way we have a multiple classes. So now I will open all the classes here. Now you can see long class. So this is also finally class. Again, this particular class is extending from this particular number, and it is implementing from the comparable. Getting the point? Now you can see minimum value, maximum value, and it is having some additional properties here. So what are all the properties we are able to see? Most of the methods it will be same here. Now you can see toString method. So how this particular toString is implemented? It is expecting two parameters here. So what are all the two parameters? Long I and radix here. So now you can see it is doing some internally other operations here. So what I want to provide here, along with this particular primitive type, we are going to have each class here. For this particular long, we identified the long, and for this particular float, we are going to have float here. So same way, double. Let me open this particular float also. This is the float class. Now you can see it is extending same information. So these particular classes we'll call it as a vapor classes here. Okay. So any questions regarding this particular primitive and vapor classes?
Sir, primitive class is primitive type is just integer means, for example, it has only that kind of property. But wrapper class, it has so many methods. Uh, am I right, sir?
Yes, vapor class it is an object class, like how we define this object here. Now you can see. So what
Yes.
we are trying to do here, we are creating the value method. We are having
Yes.
constructor. We are having square method. Same way. So this particular vapor classes will also do the same operation. But here, this integer class it will do the purposes it's different. The object class purpose is different here. But internally, we are going to create an object, and the objects will going to store in the different heap memory location. And if I want to create an object, we are going to call the constructor, or we are going to come up with a static method to create an object. So this is the functionality we are having same in the integer and the box classes. But this functionality we don't have inside this particular int, because it is a primitive type. So primitive type cannot have a object functionality here.
Sir, in the previous program, if we give 200, why that object class returns 100, sir?
Mm, where that example? Okay, 100 is returning because here what we are doing, we are trying to returning IOB 100. So this value will return 200, and this particular value again this is the different example. So up to this is the different example we discuss, and this is I'm trying to explain here. IOB we are making as a 100. Now you can see first one is it is returning 200 because of the line number 11 we are having println statement, and here now observe carefully the line number 14 in basically it is a primitive type that is called int. So IOB basically vapor type. Here we are trying to converting integer. So you can see here the naming convention is different here. Integer is different, int is different. But internally we can easily converting into to integer, integer to integer. Okay, so here we are doing the two types of conversions here. So here first one basically this is the integer and this is we are calling as a integer. From integer to into automatically we are converting from int to integer. Automatically it is conversion. So this particular example only we are calling unboxing. Getting the point? Auto boxing and auto unboxing here. Unboxing basically primitive type to vapor class we are going to convert and boxing basically vapor class to primitive type. It's like a object to primitive type. Okay, and primitive type to object here. This is we need to understand here because here we are not converting explicitly. So just we are initializing the values here. So how we are initializing the value? So now if you observe, basically 100 is a value. This value, what we are doing is we are trying to converting into this particular integer object. And whatever this IOB basically it is a object type. For example, if I'm going to print this IOB, this IOB, what is doing is it is trying to print this particular value. IOB basically it is trying to print this particular value here. Okay, same way IN is a primitive type. It is trying to hold the value only, but only the difference is here. So these two are holding the value, but only the difference is basically IOB. With the help of this particular IOB, we can call some additional methods here. For example, IOB dot you can call double value. We can convert the integer value into this particular double. So now observe carefully. If I'm going to run the same example, this is trying to converting double type. And here we are not converting anything, just whatever the value is stored here, the same value I'm trying to print here. But what is the additional functionality we are getting here? IOB dot double value we are getting. And the same way we are having IOB dot float value. Okay, int value, long value, so byte value, short value. Getting the point. So this is the way we can convert the value into different data types here. So now you can see these are all the constants here. Now call this particular size here, IOB dot size. What happening internally? Whatever internally it is returning 32 here. Okay, so this is the default size of this particular integer object here. Getting the point. So along with size here, we have a additional methods like a compare method. Getting the point. Hash code method, maximum method, minimum method, number to leading. We have a lot of method we are having. We have a lot of method we are having. So now you can see reverse method we are having. So you can call this particular reverse method and you can provide this particular IN. Now, whenever we are trying to do this particular reverse here, now you can see, so whatever the maximum value we are having, it is trying to reverse this particular numbers here. So you can see, so what is doing internally, it is trying to do the hexadecimal operations and it is trying to converting reverse byte and it is doing this operations here. Okay, so this is the another important like decimal related example we need to understand this particular the conversions here. But we are having so different methods which are available inside this particular object class. But those informations we are not going to get inside this particular primitive type. For example, if I'm trying to write in dot, I'm not getting anything here. So we don't have a methods here because it is a primitive type here. Okay, so this is we need to understand very carefully here. So this is the differences between primitive type as well as the object type. So object type again we are having the like what are how many data types we are having, something like 1 2 3 4 around 9 data types I hope. So this particular 9 data types we will call it as a vapor classes. Any questions here?
Got it, sir. Thank you.
Anything I'm missing? I think here I'm missing double. Now you can see, so this is, we'll call it as a, this section we'll call it as a primitive type. Okay, this section we'll call it as a primitive type. Same way, we'll have all the classes. So how many primitive data types we are having? Same way, we are going to have, so those many vapor classes here. Getting the point. Those vapor classes will convert automatically into primitive type, and the primitive type automatically it will convert the same vapor type here. Okay, now how we are doing this? So because integer is a vapor class we are defining, and IOB we are providing 100 value, and internally we are incrementing. Again, I'm trying to storing into this particular primitive type. So if this is very important, we need to understand here. So IOB plus IOB. Basically, IOB is an object here. IOB is an object here, but directly we cannot increment the object here. Directly we cannot increment this particular object. So what is the best way of incrementing this object here? What is the best way of incrementing this particular object here? Internally, this IOB will convert into a primitive type, and once the value is converted into the primitive type, the value is going to increment it, and whatever the incremented value we are having, the value again is going to store into the vapor type here. So these are all the steps it's going to perform. So first step, basically what we are doing is this object, this IOB, it is a vapor class type. Now what we are doing is we are trying to converting into primitive type. Getting the point. So once it is converted, second step, what is doing it? It is trying to incrementing it. It is trying to increment the value. So once it is incremented, now whatever the value, the incremented value is available. What is the data type? Again, it is a primitive type here. Again, it is a primitive type here. Now the primitive type basically what is doing it? It is trying to converting it from primitive type to so object type here. So these many operations are implemented internally. Whenever we are trying to provide this particular plus IOB, these are all the three steps are performing internally. This is very important because IOB is a object type. Object cannot increment it directly. If this particular value it needs to increment, first we need to convert into primitive type, and later it will increment the value. Again, the incremented value having the type called primitive type, and finally the primitive type again it will convert it into the object type here. Okay, so this is very important, we need to understand. But everything, these are all the three steps internally it is performing. Getting the point. Explicitly we are not performing any operations here. Okay, so this is one of the another important information we need to understand. And finally what I'm doing is I'm trying to converting whatever the primitive type we are having, and so the primitive type I'm trying to store here. So basically IOB is of vapor classes, and the vapor class I'm trying to store into this particular primitive type, and finally I'm trying to print this IOB. Getting the point. This is the another important example. What we are doing is we are trying to converting AutoBoxing, auto unboxing here. So any questions? Okay. So if we don't have anything, now I'm going to discuss one of the important concept to call annotations. So this is basically, so this is the core of annotation we are discussing from here. And in our upcoming classes, we are going to create a multiple annotations here. Okay. So let's write a simple example on this particular annotations here. Basically, what it will do this particular annotations here, and this particular like Java is going to support one of the important feature called annotation, and it is going to enable this particular supplementary informations here. It's like a additional information we are going to enable with the help of this particular annotation concepts here. Okay, so we'll try to define the annotation, how it is going to write, and what are all the syntaxes we need to write here to write the simple annotation example here. Getting the point? And here, so once we define this particular annotations here, what happens here? So it's going to leave the semantic program unchangeable here. Whatever the program we are going to write here, so it is not going to modify here. So like it's not going to unchange here. So this is important information we need to understand. The first one, basically, whenever we are trying to define the annotation, so it's going to add additional information into this particular source file. Getting the point? Additional information we are going to add into the our source file. Source file, basically, wherever we are trying to define this particular annotation, the particular example we'll call it as a source file. So this is a one kind of source file. Okay, and on top of this particular class, if I'm going to make annotations, so the particular annotation is going to add additionally, and once we add this particular information, it is not going to unchange here. Getting the point? So this is very important here. And here, this information is going to use, like this annotation information, it is going to use it by the various tools here. Basically, whenever we are trying to developing the and deployment here, we are going to use this particular annotations informations here. Getting the point? So this annotations is going to work as a tools basis information here. Okay, and if I want to add some additional information, I will provide the information. So basically, observe carefully how I'm trying to create an annotation. So you can see we are having one option in the IDE. So directly we can use this particular annotation. This annotation will give you the information. So what is the name of the annotation I'm going to create? Something like my annotation. Getting the point? So this is the annotation I'm trying to create here, and you can add here from where we want to provide the information. Getting the point? So this is very important information we need to understand here. So observe carefully. Here we are having something like a retention policies here, and you can come up with the target. So target, basically, where we are going to use this particular annotation, we can enable these many information we are having, like your type at class level or parameter level. Again, we can go for the, so one more annotation. So we can use the type, use field, constructor, package, module, method, local variable. Getting the point? So these are all the different information we are having. So based on our requirement, these annotations we are going to use here. Getting the point? And what about this particular retention? Retention, basically, where we need to use this, where we are going to use this information we are going to provide, like while developing we are going to use, or while at a deployment purpose also we are going to use. Only for this particular current example we are going to use. So those three example we are having, for this particular example we are going to use. Okay, so define this particular let me define this particular my annotation first, and later we'll try to define the other additional informations here. So observe carefully what is the syntax we are following here. First, we are defining public. Why we are making public? Basically, we are going to use in the different locations here. Okay, we don't know in the which packages we are going to use, because we need to make as a public here. So we cannot go for the some additionals here. We can define additional properties, but the problem, this annotation we are going to make as a public, because with the different packages we are going to use. Okay, and this is the at the rate interface. Getting the point? At the rate interface we are going to define to create a annotations here. To create a annotations here. Okay, so this is very important here, and name of the annotation I am trying to define as this, my annotation. So this is the name of the annotations here. So whenever we are defining it, so first, basically, what we need to notice is, so this particular interface keyword, whatever the interface we are keyword we are already identified in the previous example, it is appending with this particular at the rate here. Okay, now what happens internally? So just we are sharing the information to the compiler. So this is the annotation type. Getting the point? So we define the class type, we define the interface type, we define the enum type. Now we are trying to defining annotation type here. But how we are sharing the information? At the rate interface. So whenever we are defining this particular at the rate interface here, compiler will understand This is the annotation type here. Okay, and the same way I'm going to write the methods here. Same way I'm going to write the methods. So now observe carefully. Sing str. Getting the point. This is the one method I'm writing here, and into val. So this is the another method. But observe carefully. So just we are going to declare the methods. Getting the point. Inside this particular annotation, just we are going to declare this particular method. But who is going to implement this? And here our runtime system is going to implement this particular methods here. This is getting the point. So here we are just having the just we are declaring this, and the runtime system will provide the method body for this particular and methods here. So how many methods we are having here? Two methods. First one is str, and which is trying to return the string, and another method we are having val, and the value it's trying to return the entries. Getting the point. And these methods can contain the body at runtime here. Okay, so don't worry, this method implementation is going to take care of our Java compiler. Okay, so this is a very important, we need to understand it. And another information, basically this annotation, it's not going to include any extend information. So for example, extend something like a box class. Okay, if I'm going to write this particular extends here, now understand here, cannot have an explicit superclass. Getting the point. So we cannot make any explicit superclass here. So this is very important here. We are not going to make any explicit superclasses here. Okay, internally it is already included one super interface here. So that is called annotation. Getting the point. For this particular enum also we already identified. Internally it is extending one abstract class called enum. Same way for this particular annotation type, internally it is trying to extend this particular super interface, something like annotation. Now you can see this is the annotations here, java.lang.annotation. So this is coming from the which package? Now you can see java.lang.annotation. So this particular interface by default, it is going to extend it to this particular my annotation. Getting the point. This is very important, we need to understand. For this particular enum, what is the abstract class? That is called enum. Now you can see what we are having here, only equals method, hash code method, toString method. Any additional information? Here we are having annotation type, but here we are having some conditions here. Here we are having some conditions. So this condition we'll see later whenever we are trying to discuss about the generic concepts here. But observe how many methods we are having? 4 methods here. So inside this particular annotation interface, we are having 4 methods. The 4 methods we are going to implement. Getting the point. Because right now we are not implementing anything. Everything is going to implemented by our Java compiler. Because here also we are defining 2 methods. These particular 2 methods and the additional 4 methods, all the 6 methods are going to implemented by the compiler informations. Okay, so this is very important, we need to understand here. So the simple example, how I am going to use this. How I'm going to use this example. Okay, so observe carefully. Before going to use this example, I'm going to add retention policy. On top of this particular annotation, I'm going to provide the retention policies here. Okay, so now you can see, basically retention is also one of the annotation. Retention is also one of the annotations here. Okay, so this is very important, we need to understand here. So I will explain this particular retention first, and later we'll try to identify so what is the best way of writing this particular retention here. Now you can see, so public interface retention. Getting the point. This is the one more annotation, but this annotation what we are doing is we are trying to use inside this particular, like on top of this particular my annotation class. And what it will do, so now you can see retention policy here. Retention policy value. Getting the point? Retention policy value we are providing here. Now, if I'm trying to expand this retention policy, now you can see retention policy basically it is a enum. So first we are having source, second we are having class, and third we are having runtime. So these are all the constants. Yesterday we discussed about this particular constants here. Okay. So see how they are creating public enum retention policy, and they are having with the three constants here. So what exactly the each constant will do? You can read this. So annotations are to be displayed at compiler. So whatever the annotation we are going to define, so those annotation will displayed only at compilation phase. Okay, and this particular class. So now you can see annotations are to be recorded in the class file. So it's nothing but at runtime. Runtime also the annotation will available whenever we are making this particular retention policy as a class. And what about this particular runtime? And this particular runtime basically it is available compile time as well as runtime, and it is going to be documented here. Getting the point? So this is very important here. Basically, this is the combination of this particular two, source and class here. Source and class here. But how I am going to write this particular retention policy? Observe carefully. So they created one annotation and they define the one method called value, and it will try to return the retention policy type. Okay. Same way they are making as a retention documented. So on top of this particular annotations also, they are trying to use the same retention annotations here. They are trying to use the same annotation, but I am also going to copy this into our annotation. So this is already we declare here, and I'm making like I'm trying to rename this. Getting the point? This is very important. We need to understand. Now we understand this particular retention policy. So once we understand this particular retention policy, now we'll try to identify some additional methods here. Okay, so before going to provide the some additional method, now what I will do, I am going to create a one class here, something like one class I'm trying to define. The name of the class I'm going to create as a meta, and inside this particular class, now what I'm doing here, I'm going to define public static void ANNO. ANNO is nothing but annotation. So the name of the method I'm trying to make as a annotation. So here on top of this particular method, I'm going to use our annotation. So how I'm defining? So this is important. This is the way we are going to define this particular annotation. So why this annotation is giving me an error? Because is expecting two values here. What are all the two values? First, we need to provide the str. Getting the point? So str, we need to provide something like annotation example, and what is the another one we are having? Val. So what is the value I want to provide? Something like 10. Getting the point? Because in our my annotation we define the two methods. First one is str, second one is val. So the val will return the integer value, str will return the string related information. We'll discuss about the string related information in our upcoming classes here, but observe how I'm trying to use this particular annotations here. Okay, here what I'm doing here I'm going to create an object. So which object I'm trying to create here? Something like meta me is equals to new meta. Okay, so I'm creating an object here. So using this particular object, basically what I'm doing here, I'm trying to, so let me use the try block. So why I'm using the try block? Here we are going to get some exceptions here. Because of that, I'm defining try block here. But observe carefully, me dot get class. Me dot get class. So this get class method is coming from the which class basically is coming from the our object class here. Okay. So what is the purpose of this particular get class? It will try to return the current class object. What is the current class object here? It is not something like meta. Okay, now you can see I'm going to return this class information. Okay, now I'm getting this particular class. So once I get this particular class, now later what I'm doing here. So observe carefully. Later, once we get this particular class one dot get method. Getting the point? Get method. So now understand carefully what we need to provide here. So name of the method, if it is having any parameters, we can provide the parameters. But our method, it is not having any parameters. So observe carefully, get method I'm providing, and this is expecting name of the method. So what is the name of the method we are having? A and NO. And any parameters we are having basically null. Okay, right now we are not having any parameters here. Now what I will do, why I'm getting this? Okay, so basically this will return method type. This is we need to import this method java.langlet reflect here. Okay, so this is the method I'm getting. Once I get this particular method, now what I'm doing here, now observe carefully, method dot get annotations. Here we are going to get this particular annotations here. And so I can provide the name of the annotations also. Let's see, here we are having get annotation. So this method is expecting one parameter, and we can provide the name of this particular parameter. Something like, what is the name of the parameter we need to provide? My annotation dot class. So it will return my annotations here. Okay, once it is defined here, now what I'm doing is I'm going to print the value. So here annotation dot str annotation dot value. Okay, these are all the two methods we define inside this particular annotation, and I'm going to write catch block. So simply I will try to handle exception. I will try to handle the exception, and I will use a print to stack trace. Okay, I'm going to run this example. Sorry. Here we don't have a main method. Here we don't have a main method. Okay, now what we need to do basically? Basically, what you understand here, this is very important we need to understand. Here basically, I created one meta class here. Inside the meta class, I'm having one method called annotation method, and the particular method is expecting the particular method is having annotation. So basically, I want to load this string as well as this particular value. To load this particular information, what we are doing is, first we are loading the class information, and later we are loading the method information, and later we are trying to load the annotation. And for this particular annotation, what are all the properties we passed here, I'm trying to print this. So finally, what I'm doing here, I'm going to call the main method, and I'm going to call this particular annotations here. Okay, so this is a now observe carefully. Annotation example we provided as a string parameter. Okay, and the value we given as a 10. The particular value we are loading here. But how we are loading it? So this is the code to load this particular example here. Basically, this particular get method, it will try to throw an exception. So if you observe, now you can see no such method exception. Getting the point. This particular method is trying to throw no such method exception. Directly, you can handle this particular no such method exception, or you can come up with how we define like this exception. Getting the point. So this is the way of trying to load this particular values. So whatever the value we define to this particular my annotation, we are trying to load this particular way here. Okay. So any questions? Any questions regarding this particular simple annotation example?
Sir, in real time, what kind of scenarios we use this concept, sir?
So basically, in real time, based on our requirement, we are going to create a multiple annotation. Most of the cases, we'll create annotation for the validations purpose. For example, if you are having some fields, I want to provide only specified pattern. Like I want to provide 1 to 9 numbers, like A to Z capital letters or A to Z small letters. I don't want to allow the special character something. So in that case, we are going to define the validation annotations, and along with the validation annotations, we are going to write the conditions here. Okay, and we'll try to define the like specific environment annotations. Getting the point. And if you see the default annotations, like we already identified, override. So this is also one annotation. Now you can see this is the retention is having only source here and element type method. This particular annotations we are going to use only at method level. Getting the point. But this information we did not add it for our annotation. So wherever we can use right now. But using this particular target, we can make some restrictions here. So how we are making this particular override here. So this is available only at the compile time. And this override annotation we can use on top of the methods. For example, the override annotation, where is our meta? If I'm going to use here, if I'm going to use on top of the class, now you can see it is getting an error here. Why it is getting an error? Because this is the place, it is not the suitable place, because we are having some restrictions here only on top of the method only we can use it. So now here we can use this particular override here. But basically this override, most of the cases, how we are going to get, whenever we are trying to define the method in the super related class or interfaces, then we are going to use this particular annotations here. Okay, same way we'll try to discuss the different annotations in tomorrow's session. Like once we familiar with this particular annotations here, now what I will do, I will try to come up with one of the additional concept to call some restrictions, input output streams. So tomorrow, once we completed this particular annotation example, we'll try to define the input output stream. So before going to discuss the input output stream, we'll try to write a multiple example, and we'll see what are all the default annotations we are having in our Java language, and what annotations we can define as a custom type. The single example we define something like my annotations here. Okay. So any questions or regarding our today's session?
Okay, sir. Thank you. No question.
Okay. So thank you. We'll continue tomorrow.
Okay, sir. Thank you.